Everyone, good evening. Today, let us try to solve this problem. The given problem is for the H parameter equivalent circuit, find the voltage gain, assume a load resistance of RL. Okay, so let's try to apply KCL at input port. Okay, so apply Kirchhoff's voltage law at input port. See here, so whenever the current is entering, this is positive, negative, and polarities are already marked. So whenever the current is leaving, the polarity of voltage is V1. So plus V1, drop is minus. What is the drop? Minus the current. Whenever the current is leaving, the leaving polarity is minus. Minus I1 into H11. Minus I1 into H11. And what is the polarity we have here? Minus H12 V2. So now that equal to 0. I require the value of I1. So I'm going to write down V1 minus H12 V2 is equal to I1 H11. Excuse me. We require I1 value. So I1 is equal to V1 minus H12 V2 divided by H11 is the value of I1. Okay, so now if you write down at output side, the leaving current at this port, the leaving current is I2. So I'm assuming this current as some Ix and already some current is flowing in this branch. So try to apply Kirchhoff's current law at node. Okay, so what is the entering currents to this node? The entering current is I2. So entering current is I2. The leaving current is in this branch is Ix plus H21 I1 is the leaving current. What is the voltage at this point? V2. So since this is also short circuited, what is the voltage at this point is V2. So I can write down I2 is equal to Ix. How to write down the current? Ix in this branch. So the current Ix, how to write down is Ix is equal to V2 multiplied with what is the value of H22. So the value of H22. Okay, so what is H22? So you can see here H11, H22. Okay, so the value of H11 is ohms, H22 is mhos. So this value is in mhos. Okay, so directly we can write down as H22. Okay, plus H21 I1. So here we require only the terms of V2 and I1. Sorry, V2 and V1. So how to find out is there should not be any I2 or I1 terms. Okay. So now for this, what we are going to do here is we are going to represent. So how to write down the current I2? So the current in this branch we need to write down. Okay. How to write down the current I2? Okay. So generally, if you take the current I2 is like this. So current I2 is equal to high potential. High potential is V2 minus 0 by RL. But this current is flowing. So I2 current we assumed is like this, but the current which is flowing is coming in opposite direction. So therefore, this I2 current is opposite. We can write down it as minus V2 by RL is a current which flowing in this direction. That is equal to, so here V2 into H22 plus H21. So we don't want I1 value, but we require only V1, V2 values. So for that, we are going to substitute that value as V1 minus H12 V2 divided by H11. So now when you segregate, so if you have any doubt, you can see my previous lectures how to write down. Okay. So if you want a clarification for this, how to write down the current I2 is very simple. So here you are having an resistive load, and you assume this is negative terminal and this is positive terminal. This is 0 volts. Whenever the current is entering, this is positive, negative, and we need to write down this current in this direction. Therefore, the current will be flowing in this branch. So the voltage at this point is the voltage at this point is V2. Okay. So now whenever the current is flowing like this, what is the leaving polarity? So how to write down I2 is the leaving polarity is 0, and the current is leaving like this. What is the leaving polarity? Minus V2 divided by the resistance of this branch is RL. So this is the resistance of this branch. That's how we are getting this one. So generally, if you have any doubt, you can also take it as our reference. Already we told. So this is the default I2, and here we have V2, and here we have positive terminal and negative terminal. Now how to write down the current? I2 is equal to V2. What is the leaving terminal? Minus 0 divided by RL. So this current is flowing from top to bottom, that is of positive polarity, but this is going from bottom to top. That's why we got a negative terminal. That's how we obtain this value. So this is only for the clarification of how to take the currents. If you take the current in downward direction, you got positive. If you take enough, we'll get negative. That's all. There's nothing else mistake. So you should be very focused while you solve these kind of problems. So now, therefore, we have got that as, so the answer is minus V2 by RL minus V2 H22 is equal to H21 V1 divided by H11 plus H, sorry, minus H21 H12 V2 by H11. So just I am multiplying these terms. So now when you take it common, we require only the V2 value. Okay. So take V2 as common. Therefore this is minus 1 by RL minus H22. So when this term comes to this side, this is nothing plus H21 H12 divided by H11 is equal to H21 V1 divided by H11. So I'm taking the LCM as RL into H11. So here minus, you're going to get H11 minus H22. Here you are going to get RL H11 plus H21 H12 into RL is equal to H21 V1 by H11. So H11 will get cancelled out. So from here I am writing V2 by V1. So this term I am bringing to the denominator. So therefore this is equal to H21 into RL divided by minus H11. So the same term minus H22 RL H11 plus H12 H21 RL. So this is the voltage gain what it is asked in the problem. Hope you are able to understand and how to find out the voltage gain. So just very simple, apply the KCL at input port, apply the KVL at input port. See that the complete equation should consist of, so I2 and I1 term should not be there, only V2 and V1 terms should be there. So already I1 is expressed in terms of V1 and V2. So this also we expressed in terms of V2, and the current is flowing in opposite direction. As already I told, the current flowing in this direction will get minus V2 by RL. Substitute and express in the form of V2 by V1. Hope you understood the problem. If you feel the content is useful, please like the video, please share it with your friends, and if you have still any doubts in application, let me know in the comment section. And if you're watching the channel for the first time, subscribe to the channel KV Tulasi Ram. This is a free channel for the development of student and faculty. So thank you for watching. We'll meet in the next video. Yours Ram.